right? So I don't know, it feels like it's been out forever, but I think it was only just after the last meetup, at the end of the last month, yes, that Raspberry Pi announced their second Pico-based board. So the first one you've probably all seen, but this is their first board is a Pico. It's relatively cheap, and it has their RP2040 chip right in the middle there, and a few other, maybe I'll put it sideways, a few other parts. Quite minimal board, but yeah, it's got a crystal and a SPI flash chip, USB connector, and a button. And what they've done in their next board, which looks like this, is they've added a Wi-Fi chip in that big metal can. So otherwise it's basically the same, just with the addition of that can, and then you can see
use the antenna, yeah,
and a cavity antenna. So the antenna itself is this thing here, which is the lack of copper within the PCB in a very, very, very special shape, so that it radiates at the right frequency, or it can capture photons at the right frequency. So I think they use the same cavity antenna on their Raspberry Pi actual computers. They've licensed the technology from a company,
ProAnt.
ProAnt.
That's it.
ProAnt. It's written on the back of the board. So that's pretty cool. Keep costs down, I guess. Obviously, depending on the licensing fee. But so this board, the Wi-Fi chip that's used in here is the same Wi-Fi chip that they use. Maybe not exactly the same, but it's very similar to the one they use on their Raspberry Pis as well, which is also the same that we have on our PiBoard D series, which is in a much smaller package. So you can see the difference. So on that the silver thing up there compared to that silver thing, it's the same. It's not exactly the same, but it's a very similar chip inside. And it does have Bluetooth, but Bluetooth is not yet enabled on the on the Pico W board. So this Pico W obviously stands for wireless, has all the features you'd expect from a Wi-Fi board. So if I do a demonstration, share screen. I guess you can see. Yep. So yeah, you can import network, and network.wlan gives you your object and activate it, and I can scan for networks, so you can see all the networks around. So I can connect, so this will connect to my local network here. It's just running a command through MP remote in the background. It's just sent a command to connect to the network. You can use that on obviously any board that I have here, but this way you don't get to see my password. So it's now got that IP address, so I could ping that. And it should get a response. Yep. So that's pinging this Pico board. And obviously you can do all the other things that you're normally used to. So I think your requests is installed on here. Yep. So it's got HTTPS support. So let's try. There's a special test page you can get here. So that's over HTTPS. Yep. So response.txt gives you the content of that. And then I should close that. Should also just try a normal HTTP request. It should be a little bit faster. HTTPS is obviously a bit slower because you have to, you have to do all the security stuff, which is lots of encryption. the other, so yeah, up of 3. Let's see if we can run that. Just look at the performance. So run a server, and on my PC, I can do client 192.168.20. Oops. 20 and length, maximum length of the TCP packet 1400 bytes. So yeah. So this local network here, we're not that close to a router, but we're getting nearly 4.5 to 5 megabits a second. Should be able to get a bit better, but it's a bit noisy here at the moment, I think. You can also do UDP testing. So that's just capped at 1 megabit, which it's getting through all the UDP packets there pretty much without error. But if we increase the UDP rate, B or R, to say 5 megabit, oops, this should be a B. Yeah, so now it's trying UDP packets at 5 megabit, and you can see not all of them are getting through. It's sending about 782 and only 500 or so get through. So you're definitely hitting the limit there. Anyway, you can see the performance is quite good. That's about similar to what I would get on an ESP32 in this setup, or a Pico W even. Yeah, so it's basically what you would expect from an ESP32 or anything else that has Wi-Fi and MicroPython. You can now do on the Pico, and hopefully not too long until you can also do Bluetooth, because there's a Bluetooth within that chip as well. So the way they've done it is, because the RP2040 doesn't have that many GPIO, and some of them needed to be used to communicate with the Wi-Fi chip, they've added back some GPIO from the Wi-Fi chip itself. So the Wi-Fi has a few general purpose IO pins, and 3 of those have been exposed back to the user in Python. So you gain back 3 pins. So you lose 3, I think, from connecting to the chip, but then you gain them back from the chip itself. And they're just general purpose IO pins. And one of them is connected to the LED. Yeah, so if I think my machine pin LED. So this is actually alias to this wireless LAN GPIO 0. And if I make that an output and turn it on, let's try on, then yeah, it turned an LED on the hard for you to see, but there's a green LED that turned on, and if I turn off, it turns the LED off. But that's actually, that LED is controlled from the Wi-Fi chip itself. So that was something to keep in mind, I guess, is that the GPIO was slightly different for those 3 pins. But otherwise, you get PIO. One of the PIO state machines is used to communicate with the Wi-Fi chip. So you've lost one there for your use, but I think you've still got 7, so that's pretty good. It doesn't use the other core. For the Wi-Fi, the Wi-Fi driver is the same one on the Pico D. It uses interrupts to service the Ethernet packets coming in. It's not there's no RTOS there, so it's quite lean and efficient in that respect. So that's how that works.
Damien, with regard to the PIO, was that done presumably because SPI resources are in more limited supply, or?
No, it's done because the communication is not a SPI exactly. It's a half duplex SPI, so there's 1 pin for input and output.
Oh, okay.
So to save pins, the input and output are multiplex. So it has to switch over from one to the other.
Did the chip always support that, or was it
Wi-Fi chip?
Yeah.
I think they've just wired them together.
Right. Okay. Yeah.
And it just works because you're only ever going in one direction.
Yeah. Makes sense.
Yeah.
Huh, okay.
So yeah, it's got, so when it was announced, there was support in the Pico SDK, and support merged into MicroPython just as it was announced, which was last month. So this was, get rid of that. Where is it? Yeah, here was, so this 30th of last month. So it's got, yeah, a new board, and the Wi-Fi driver were added. So there was, yeah, integration of the Wi-Fi driver was sort of the most tricky bit, and then the definition of the new board was relatively straightforward once the Wi-Fi driver was there. So that will be, I think, a good addition to the RP 2040 port, and hopefully it has already, I think, as Matt alluded to, brought a lot of interest and even more people to MicroPython, because using Wi-Fi on a microcontroller is tricky, you know, at the best of times. So having MicroPython to help you do that is a bonus. And you can still program the Pico W in C. So the Wi-Fi driver has a C API, and you can program using the Pico SDK. So, and people are doing that. But if you want to have like an asynchronous web server serving up multiple requests, and then doing other things in the background, doing that in C is obviously tricky. I think there is actually support for FreeRTOS now as well on the Pico. So that does help you to do multitasking. But having MicroPython there with first-class support from the beginning, hopefully will help people get the most out of this board. Yeah, that's all I really had to say. But if anyone has any questions, please ask.
Definitely brought a lot of buzz. Like, I always have trouble keeping up with everything that's going on MicroPython related, but this last month has been a bit outrageous. Lots of people have picked up and run with it.
It's interesting though, because why does this make more buzz than the ESP32 or something? Like, what is it that captures people's attention in this situation? I don't know how to answer that. I don't know what the answer is, but I think
it's
Yeah.
the price. So what it is, so the 2040, like the Pico by itself, apart from PIO, which is absolutely fantastic, no doubt, like a game changer for many things. But other than that, was a really lackluster board that you couldn't really do a lot with, right? And the fundamental thing it was missing, if it didn't have the other stuff, was a radio. And now they've added that, and like that's all they added, but that's all they needed to add. So now you've got, you know, a capable microcontroller with PIO, and you've got connectivity, which is I think it's the thing that everyone wants. Whether they use it or not is beside the point. I mean, how many people, you know, buy things thinking they're going to use this and that and whatever, and then they don't. They just get a drawer full of them. But
I feel targeted.
Sorry, what?
I feel targeted.
No. Everyone does. Like, you know what I mean? Like, you have grand plans. I wouldn't do all these crazy things with this device, but then, you know, you generally don't.
Yeah.
But you know, PIO and a radio is the thing. You know what I mean? Like,
I understand, but to 2 points. ESP32s are also pretty cheap. And the other point is, why was the Pico on its own also very popular? Because it was very popular for just a simple microcontroller.
because of its price.
There were a lot of cool projects out there that were made.
Right, because you had like MicroPython and CircuitPython on the RP2040 on the Pico, right? Which was, I mean, Adafruit brought a stack of people in as well. But you've got Raspberry Pi's branding, like you got their marketing, you got their.
They're already everywhere. Yeah, Raspberry Pis have had such a big name in, especially the tech hacker community. And
there's a level of trust with them that is just you just can't beat. And you know, when you know, yeah, it's. I mean, look at the fact that there was no Arduino for ages with it, And when it did come out, it was terrible because it was this hacked on thing, right? And people still persevered with it when they would have, you know, rage quit any other type of microcontroller if they couldn't use it that way, just because of the whole Raspberry Pi thing. Like, it's just their marketing reach is just insane.
I think
you have to remember that
numbers are a good point.
ESPs are actually
Brand as well.
hard to use for new people. Like, to flash code onto them, you've got to install either some random third-party GUI tool that's a bit iffy, or the official things are command line tools, which a lot of people are very uncomfortable with, especially if you have to install Python first, yada, yada, yada. And then most of the time you've got to find some boot jumper switches to wire. A lot of boards don't have that boot switch. So you got to figure out which pins to jumper together to get into a bootloader mode, and then maybe connect to it and maybe flash some code. It's a very steep learning curve for a really new player.
Yeah, the S2 and the S3 is different now with native USB. But it's also, the ESP32 is quirky. Like, it's, and I mean, look at me, everything's about ESP32 for me, but it's using their ADCs are just terrible. Like, they're not intuitive. They're not even a 3.3 volt ADC that people are used to, and people don't know how to, you know, change them. There's some IOs are input only, like on the regular ESP32 that trips people up all the time. You know, the whole IO mux thing, people just don't get. They don't understand where's the, you know, where's the UART pins? You know, oh, this board doesn't have UART pins, I'm not going to buy it. They don't know that they can use any pins for UART, right? It's, you know what I mean? It's just all obscure. Where the RP2040, the documentation was fantastic when it came out, right? And the support for it was fantastic. And the people that jumped on and made really cool demos with it, they didn't do the regular stuff that people did on a, you know, here's a web server, here's a whatever that everyone does, right? What did they do? They did, here's HDMI, like out of a microcontroller. Like, you can't do that on an ESP32, right? Here's proper VGA. Here's, you know, PIO driving 1,000 neopixels. You can't do that on an ESP32. You know what I mean? They were doing things that really made the board shine, that made it separate from everything else. Where on the ESP32 or any other thing, it's just all the same stuff.
I think, yeah, Raspberry Pi knew how to get the foundation, knew how to get the hackersphere on board. They contacted people like you, Damien, well before launch, so that to get support on the ground for day one, so that they could hit in a big way. And there was blogs all over the place. There were those guides. There was software support for platforms ready to go, which ESP, yeah, they're involved in the open source community, but it's been a very slow build over the years. So I think they did well with that marketing to have a really big bang on day one.
Yeah.
I think the other thing that made a big difference was that they hired Alistair Allen a while ago, and he's done really outstanding documentation.
Yeah,
And the documentation came out the day that the W came out, and it was good.
It was thorough, really thorough.
Documentation was a big deal. Yeah. Brand recognition, as everyone's mentioned, is important.
There's still no documentation, proper documentation for the ESP32, right?
ARM-based.
Something, it's conflicting information everywhere. You got to rely on third-party blogs.
I think the Raspberry Pi is more trustworthy as well. Like, what trustworthy ESP32 can you get for $6 realistically? You can get like some Chinese generic board with no name with Rover spelt wrong on it. I looked at one of mine recently and it actually was. So I don't know what that's about, but yeah.
Yeah. Good. I mean, I was in the middle. I was sort of in the midst of the other side of implementing and knowing about it beforehand. So I didn't get to see all this launch and documentation. So it's interesting to hear all these points of view.
The launch wasn't the first launch, like just the Pico. It wasn't instantaneous success. There was a lot of question. There was way more people questioning why than there was people jumping on.
Yeah, that's because it was very out of the blue.
It was out of the blue. It was only a Cortex M0. Like, even though it's souped up in terms of speed in 2 cores, but it's still, you know what I mean? There was a lot of people saying, why? Where's all the rest of it type thing? And it wasn't until people started actually leveraging PIO and doing things that no other micro can really do, unless you're talking about a really high-end STM32, you know, or an NXP or something else, right? And then people were going, okay, that's just insane. For that price, you know, for $1 for a microcontroller, and you can build a HDMI device with it. Like, that's just crazy, right?
Yeah.
And look, it's still doesn't have pickup in a lot of areas. Like at work from other departments, people are very hesitant, very like, what is this chip? This is not an established player from a silicon perspective. And it's only a Cortex M0. What are you going to do with an M0? That's titchy tiny. Like there's still a lot. That's why one reason why there's still tens, if not hundreds of thousands of them available for sale, because I think the professional market has not been very quick to jump on it, because you get used to the established STMs and NXPs and big players that you can trust. So it's hit a different market.
Commercial sales of the original Pico to business have been quite high. And I think we'll see the same thing with the W, but it just takes a lot longer for people to decide, I'm going to base my product on something new, than it does for us hardware hackers to say, oh, I'll buy one and give that a whirl.
Yeah, that's
one other thing I'd mention too is the chip shortage. I mean, the timing was amazing. They had good supply chain sorted out, and look,
About 3.5 months, it was the only chip you could get.
It still is in a lot of cases. Like, yeah.
In terms of long-term planning, they have to overcome the issues they've had with the Raspberry Pi availability, like the compute modules and things. They have a reputation when you're using them for commercial use of often not being available, and that may not be the case with the Pico. They still have to overcome that and prove that they are a long-term supplier, reliable supplier of the 2040.
Yeah. Yeah, well, time will tell, I guess, with that. But there are probably, I think, 1 million units available in stock in distributors.
There's
Well,
sold
they committed to
over
5
2 million
million
now, so.
chips, didn't they?
Sorry?
Evans said that he plans to make 2 million by the end of the year.
Yeah.
So it should be cool.
And
But
there's
they-
sold over
didn't
2
they
million in the
commit-
first unit.
Didn't they commit to 5 million, like the fabbing of 5 million chips? Like, wasn't that part of why they got their deal and their price and everything else was? I don't know for what.
Yeah, that's 2 million Picos, not 2 million chips.
No, I know that, but didn't they commit to 5 million? I thought they.
Yeah, I
committed-
think they did.
Yeah, right. I mean, that's a massive commitment,
Yeah.
especially on a product that at the time when they committed hadn't launched yet. Like, that was like that's why they got Fab Time, and that's why they got their Ripper
Yeah.
licensing deal.
Yeah.
A lot of chips.
Well, yeah, they just, I guess Evan had confidence in what he's done.
I mean, it's a very fast dual core Cortex M0. There's nothing wrong with it being a Cortex M0 except for the fact that it's got no memory. Sorry, wrong. It's got a little bit of memory. It doesn't have enough memory, and it doesn't have the ability to do external memory, which really
That is a problem, I think.
it sucks. Like it's, and especially now with the radio, like really not enough memory.
Well, that's not necessarily true. Is it?
It's
Potentially.
not enough memory for a lot of things. You're going to struggle to do graphics on it, of graphics of any like sizable screen. Like I've had a couple of projects I wanted to use it on and just couldn't. Like, there was nowhere near enough RAM on it, because I'm used to hanging RAM chips off STMs to do stuff.
Yeah,
And-
but that's not. I mean, for a traditional microcontroller, 256K of RAM is a huge amount, and you're not usually adding SD RAM.
But that's not a traditional microcontroller anymore. Like, and so now it's 512K, right? Without adding additional. And additional now you can add, megabytes and megabytes, like 128 megabytes of additional PS RAM, right? You can do, octo SPI PS RAM on a lot of the high-end micros now. So it's super fast. But it's not even that. It's just like SSL. Like it's going to trip up like the SP32 did. People can do basic SSL stuff, but the second they want to do something really full on, sorry, not enough memory.
Well, it does have. I mean, it has more than double the memory from the SP32 from what's available, because you don't have to run the Wi-Fi on the RP2040. You don't have to run the Bluetooth on the RP2040. All that runs off chip. So the ESP32, because you have to run everything else in the actual ESP32 itself, you've got to dedicate, 50% of your RAM to the IDF.
Yeah, but PS RAM, like every board has it. Like,
Yeah.
But
I have to grin
it's cheap.
because The first machine that I used had 56 words of memory.
Yeah, you got to remember. Yeah,
and
it's all
vacuum
in,
tubes.
that's it. It's in context.
We didn't have to do SSL, so
It does depend what you're using it against. And I admit I've gotten lazy with a lot of things with some of my projects when I've got all that extra RAM. But compared to most micros, and it is an M0 Plus, which is a big difference to the little STM070 kind of things. It's a very capable chip. There's no denying that.
Yeah, yeah.
More pins would be good though.
Yeah.
More pins and more RAM, or just a second, memory SPI bus. Then it would have been amazing.
Maybe a reset button.
You can add that. You can add
There
that.
wasn't a reset button.
Yeah, we're all never satisfied with.
I can't believe after the whole reset button thing, though, the amount of shit they copped for it, they still didn't put one on. Like that's
They couldn't, could they?
They should have. They should have. Like that's doubling down on bad. Like, you know what I mean? Like you hand up and go, yeah, okay, here's a reset button. Or put the pads and don't populate it, and let someone else populate it if they want to. You know,
You can buy a little reset button adapter.
It doesn't fit the W.
Doesn't it?
No. Well, at least a couple of the models I saw. It's just like a small little PCB with a micro switch on it, and they make a point saying that it doesn't. At least I think there are a few of these floating around, but last couple I had a look at said that it interferes with the CAN on the Wi-Fi.
Keeps Pimoroni on in business though, doesn't it, to sell the little add-ons?
Yeah, it's true.
So the problem with the Pico W is that it's not something people can replicate for their own designs, right? You can't just stick an ESP32 chip down and you've got Wi-Fi and Bluetooth, right? Like it's a great board, but you have to either use a board as a module or you're booted out of the ecosystem because you have to, do your own Infinity thing and Infineon and your own chip and your own integration with design your own stuff.
That's true.
I suspect we'll see a bunch of them drop down castellated onto other designs.
Possibly, but yeah. That'll be interesting to see if they can compete with an ESP32 module. Like Raspberry Pi might be able to compete on price, but a third party won't be able to. Like if I wanted to make a board, like a whatever, like I couldn't even come close to their price point if I was buying those parts myself.
Yeah.
So that'll be interesting. We'll see how well it gets adopted because of that.
Yeah. Interesting discussion. We should probably
good discussion.
It's definitely brought a lot more networking modules into the forefront, packages and Quests and MQTT and a bunch of all that sort of stuff.
MDNS,
yeah.
Good though. It's good.
It pushes us. All right.
How are you doing for time?
Shall we move on to the next topic?
Yeah.